So this is another question. Use normally a 150 watts, 150 watts, 120 volts requires how many amperes of current? So I think this is a question that trying to address that it's a circuit that have a 150 watt, 120 volts. So how many amperes? That is how many currents does it require to run the cycles? So A, we have 1.25 ampere, and B, we have 3.00 ampere, and C, we have 2.50 ampere, and D, we have 0.8 ampere. So this is electricity. So I think we need to look at the electricity first before we solve this question. What is, let's start with a current. What is a current? What is a current? We are starting with current. What is an electric current? Electric current is the rate of flow of electricity along a conductor. So electricity or electric current is a rate of flow of electricity along a conductor. That is the current, and it has a formula. Usually current is represented with capital letter I, and it has an SI unit. The SI units for current is ampere. Which is also represented with capital letter A. This ampere, it also has a formula, which is the current also have a formula. And the formula for an electric current is from this formula, Q is equal to IT. Q means quantity of electricity, I means current, and T means time. So it means that here we can just write, we can make I solve on the formula as I is equal to Q all over T. So this is the formula for regulating current. And of course, apart from current, we have what we call voltage. We have voltage. In electricity, we have voltage. What is a voltage? A voltage is like a driving force that transfers electrons from one point to another. Remember that in an electric circuit, we have electric current, and electric current is what gives the electricity. But before you have the electricity, there must be a movement of electrons from one point to another. And what drives that electrons, or what carry that electrons from one point to another, is voltage. And it's represented with capital letter V. So the voltage is represented with capital letter V. So, and the voltage itself also, it has an SI unit, and the SI unit for voltage is volts. So volt is an SI unit for voltage. And in addition to this, the voltage itself also has its own formula. And this formula is V is equal to IR. And where we get this is from what we call Ohm's law. We got it from Ohm's law. And of course, the Ohm's law said that the voltage is directly proportional to electric current. It means that the higher the voltage, the higher electric current. The higher the voltage, the higher electric current, according to Ohm's law. And of course, remember, whenever there is a proportionality, we introduce constant. So we have V is equal to IR. So the R here, which stands for the resistance. The resistance here is the constant. So that is why the resistance of every material, or the resistance of material, varies. And what is resistance? Resistance is like an opposing force. Is the rate of opposition of electrons to a conductor. So whenever there is an electron that tries to follow into a circuit, so a resistance is like a force that tries to oppose, that tries to protect the movement of that electrons. So therefore, that means the lower the resistance, the higher the conductivity of the material. And also at the same time, the lower the resistance, and yes, the higher the resistance, it means that the lower conductivity of the material. So this is resistance, and this resistance is measured. We can measure resistance in series, and we can measure resistance in parallel. And of course, resistance in series, resistance in series is usually arranged as resistance total is equal to R1 plus R2 plus R3 up to Rn, depending on the number of the resistance in the series. And also we have the resistance in parallel. So how do we measure resistance in parallel? We measure resistance in parallel by saying 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over Rn, depending on the number of stands decided. So this is what we call so this is for resistance. So we have to know all this formula, because as we are going on and we are solving so many questions, as we are solving so many problems, we are going to look at different cases where we are going to use this formula. So therefore, as we said, from Ohm's law, voltage is directly proportional to the electric current, and the voltage is equal to IR. The R is the resistance, which is constant. And the resistance can be arranged in series and also can be arranged in parallel. So also at the same time we have energy. We have energy of electricity. We have energy. So what is energy and what is the formula for calculating energy? So we have energy in electricity, or work done in electricity. So the formula for calculating work done in electricity is W is equal to QV. W is equal to QV. Q stands for quantity of electricity and V stands for voltage. And of course we have power. We have power also. And remember, from our basic knowledge of physics, work done is work done all over time. So therefore, we now have work done all over time. So we take this and divide it. So we have Q V all over T. And remember that Q is equal to IT from here. So you can now easily substitute the value of, or we can now substitute W. So we can now substitute Q with IT. So we are now going to have power is equal to our Q is IT V, and we have, so our power, we can calculate power with this. We have power is equal to ITV and divided by T. So therefore, this T will now cancel this. So this one can now cancel this. So you can now have power is equal to IV. So we have power is equal to IV. Power is equal to IV. This formula is important. This one too, we need it. So we have power is equal to IV, and we have V is equal to QV. So we have W is equal to QV. And apart from this, there is also what we call capacitor. Capacitor is a device used for storing an electrical charge. Capacitance is a device used for storing electrical charge. So we have a formula for capacitance, and the formula for capacitance is equal to Q. Q is equal to CV. The C here stands for capacitance. Capacitance of the capacitor, and we have V voltage and Q, of course, quantity of electricity. So it means that the capacitance can be Q, capacitance can be Q all over V. So this is for the capacitance. And so also at the same time, we have capacitance in series and capacitance in parallel. We have capacitance in series and we have capacitance in parallel. So how do we have capacitance in series? Capacitance in series, is 1 all over C effective or C total. C effective is equal to 1 all over C1 plus 1 all over C2 plus 1 all over C3 plus up to 1 all over Cn, depending on the number of the capacitors. So the capacitance can be calculated, the capacitance in series can be calculated as 1 all over C effective is equal to 1 over C1 plus 1 over C2 plus 1 over C3 plus all over up to 1 all over Cm. So this is the capacitance in series. And we also have capacitance in parallel. Capacitance in parallel. So how do you calculate the capacitance in parallel? So if C total or C effective is equal to C1 plus C2 plus C3 plus up to Cn, depending on the number of the capacitor. So this is capacitance in series and this is capacitance in parallel. So now, apart from this, we also have energy stored in a capacitance. Energy stored in the capacitance. So the formula for calculating energy stored in a capacitance is this. Where U is equal to 1 over QV, and you can play around with this. It's an average. So this is the formula for calculating energy stored in a capacitance. So, ladies and gentlemen, without wasting much of our time, I think we need to look at the questions and solve. So the question says, from the question, we have the following parameters. Number 1, we have power. Our power, which is in watts, is 150 watts. And we have our voltage. Our voltage is also given as 120 volts. And then we calculate electric current, which is unknown. So I think clearly we are going to use this formula. P is equal to IV. So we now have P is equal to IV, and our P is already given as 150, then is equal to our I times. So in 150, we have 120 here. So therefore, we are now going to have this. So we divide both sides by 120 by 120. So this one will now take care of this. Because 3 here, 5, 3 here, 4. So we have 5 over 4. And here is equal to 3. So this is our I value. This is our I value, 5 over 4, which is an E.